Hey guys, welcome. It is 7 p.m. Eastern Standard Time, 6 p.m. Central Standard Time for our Texas folks. Welcome to another Math Wednesday. We got a treat for you. So before we get into it, a couple of housekeeping things. Number one, as you can see, we have one of our other math specialists doing a guest spot here, Priya, and we'll bring her on here in a second. But real quick, how it's going to work here today, just like every other week, I know we probably have some newcomers here as well, but we have 10 practice questions set up for you. They run the gamut from PK all the way through 12th grade. And what we try to do when we put these together, big shout out to Amy for putting these slides together, is that we try to focus on some concepts that transcend multiple grade levels, meaning maybe a math concept that you might see on elementary, middle school, and maybe even your high school exam. So whether you're here from Florida, for our Florida peeps, our FTCE exams, maybe the GK subject area exams, or for our Texas peeps out there with our 7 through 12 math or 4 through 8 math or EC6, or Praxis folks, maybe your Praxis core or middle grades or high school math, we've got your back. So stay tuned. We've got 10 questions, and what we're going to do too is you can download these questions. You'll see on the screen it says text math stream 1. It's not case sensitive. You could just text that number 407-269-8829. It's going to ask you what your name is and what email address you want to send it to, and immediately we'll send you that PDF, because we know that some people like to be able to take notes on stuff. Maybe you want to go back and work the problems yourself. But our goal here today is Priya's going to go through these questions, answer any questions that you have, throw them in the comment box, and depending on how much time we have, if you have any additional questions for Priya, maybe some math concepts you need help with or some questions you have, she is here for you. So I'm not going to take time away from the star of the show. Let's welcome one of our math specialists here, Priya. They're all yours, Priya, and I'll be back on in the end.
Hey everyone, it's Priya. Some of you may be disappointed Amy's not here this week, but I promise I will try my best to fill her shoes. I don't know how big her feet are, but my feet are itty bitty, so we're going to do our best. I am the guest star this week, so you will see me and hear from me for the next hour. I know that may be a little difficult, because I don't really like my voice either. It's all right, guys. We're going to be okay together. But like Dr. Ampel said, we have lots of different things for you. We're going to try to hit all of those different subject areas, the Praxis, FTCE. We're trying to take care of all of you guys in as little time as possible, cram it all in. So let's go ahead and just get started and dive into problem 1. So problem 1, I always read the question, look at some of the answers, and we kind of try to dissect what's going on. So the problem says, the lines to the right would be considered what type of lines? Well, off the bat, just reading it, we're not really getting much information. All we see is it's asking us about lines, and they're asking about what type of lines. If that doesn't make any sense to you, we should always look at the answers to help guide us through wherever we're going. So let's take a peek at the answers. The answers tell us A, they're intersecting but not perpendicular. B, they're perpendicular. C, they're parallel. And D, they're non-intersecting. If that doesn't make any sense to you, then the answers aren't going to help you. So let's start off with some definitions before we come over here and start looking at this graph. So let's start with, what does intersecting mean but not perpendicular? Well, in order to understand that, you kind of need to know what perpendicular is. So if you don't know what perpendicular is, you're not going to be able to understand what A is even telling you, and you don't know what B is telling you. So let's try to just jump down to C and see what's happening over here. So parallel. If you know what parallel means, it really helps out. So parallel means two lines that do not intersect. All right, well, off the bat, we're saying two lines that do not intersect. When I look over here at this graph, they're intersecting. So it means that C is definitely not going to be something we're going to choose. Remember, we want to eliminate those answers that make no sense to the problem to be left with what we need to look at in order to answer the question properly. So when we look at it again, D also says non-intersecting. Well, intersecting means they touch. So if it's not intersecting, it means it's not touching. And we just talked about it touching each other. So guess what? D also doesn't help us. Without even looking at the graph, I was able to eliminate 2 of those answer choices, which is a big deal because now we only have 2 to choose from. Remember earlier we were talking about perpendicular? So let's go back to what that means. Perpendicular is when 2 lines intersect and they create a perfect 90-degree angle. All right, that fancy little sign means angle. So what does that mean in terms of this? When we look at this, can we actually tell that it's 90 degrees? No, you can't just look at it and be like, totally see it. It's a 90-degree angle right here. That's it. I'm done. It's got to be perpendicular. We actually have to do some math. So we go back and we say, well, perpendicular has to mean a little bit more than just intersecting and creating 90 degrees. And they do. When we have a graph, we want to think slope. So if we're thinking slope, we have to think of ways that the slope interacts with this graph and helps us with the answers, the words that we have. Well, for perpendicular slopes, perpendicular, the slopes will be opposite signs. We'll talk about what that means, and reciprocals. All right, well, what do I mean by opposite signs? I mean if the first slope of this line is positive, then the second slope of the other line must be negative. So it's going to be positive and negative. And what is a reciprocal? You take a fraction, any fraction, and you flip it. So let's talk about what it means to be opposite signs and reciprocals. So if we start with -2/4, let's put a negative here. If we started with -2/4, we'll take the opposite sign, which makes it a positive, and then we're going to flip that fraction and make it 4/2. Yes, 2/4 can be reduced. We're not worried about that right now. So now that we have some information, we know what the answers are telling us, let's figure out what this graph is trying to tell us. So I'm looking at this graph and I'm saying, all right, they didn't give me any numbers. They didn't really give me much to go off of other than 2 lines that are crossing through each other. And I've got to figure out if it's intersecting or actually perpendicular. Well, in order to do this, we have to pick some points. We have to look at the graphs and actually figure out what's going on. If we look at this line, let's call it line 1, or let's call it line A. Let's get rid of some numbers. Let's get some extra letters in there. If we look at line A, in order to pick a point and help us find these slopes, we have to actually pick 2 points that are exactly intersecting with the line itself. So I looked earlier and I said, oh man, this point right here looks really good. And I also found one over here. So I said, okay, those points are pretty spot on. They're perfectly on those intersecting lines. So I can just use some numbers by putting them in. So we're going to start with 1, 2, 3, 4, 4, and 5. And then we know if we go up, it's positive 1, and if we go down, it's negative 1. We have to actually name these points so we can actually do the slope. For those of you that don't know the formula that we're going to be using for slope, I'm going to put it right here in this lovely yellow box. And it is generally found on your formula sheet for the GKT. I'm not entirely sure about the Praxis. Sometimes it shows up on the subject area, but the slope formula that we're using is y2 minus y1 all over x2 minus x1. So if we have that, we're going to use it twice because we have 2 lines, and we're going to figure out what we're doing. These y2s and x2s and y1s and x1s tells us that we have 2 points. So if we use line A, let's start with line A. Okay, let's try that again. Line A. I pointed out those points, so let's write what the actual coordinates are. I have 1, 2, 3, 4. We do our x first and then our y. So I have 4, comma 1. And I also have 1, 2, 3, 4, 5. And then I go down 1 to have negative 1. But that's not how you do it. You still need some more stuff. We need to name the points. At this point, it doesn't matter which one is x2 and which one is x1. What matters is that you're consistent. So if I name 4 x2, then 1 must be y2. I hope I said that right. If I named 4 x2, then y has to be y2. If I named it x1, then 1 has to be y1, right? So we're going to take what we have and plug it into the lovely formula. Okay, we're going to get an actual slope. So let's figure out what the slope of line A is. So I'm going to start with y2, 1 minus y1, which is negative 1. So you don't want to forget that negative. Then we'll have x2, which is 4, minus 5. All right, that double negative right here becomes a positive. So I'll have 1 plus 1, which will give us a nice number of 2. And then 4 minus 5 to give us negative 1. Well, 2 over negative 1 is the same as saying negative 2. So that's the slope of line 1. I meant line A. I'm sorry, I forgot I named them letters. But let's talk about line B. Well, we have our first slope. We need to figure out what our second slope is going to tell us. So we're going to do the exact same thing. We're going to find 2 points that look really good and exact to hitting those perfect points, and we're going to number them out and write them out. So I found some points, and it looked like this one was a winner-winner chicken dinner. And, oh, look, this one over here, winner-winner chicken dinner. So we've got 2 points, and we want to make sure that we're able to label our points. So let's go with the first one. We go to the left, 1, 2, 3. So that would be negative 3. And we're going up 1. Remember, you're starting with your x and you're going into your y. So 1, 2, 3, 4, 5, 6. That would be negative 6. And it's on the x-axis. So I'm actually not going to write a number for y because I didn't move up or down on the y. So it's going to be negative 6, 0. We're going to do the exact same thing. We're going to label our points and then plug them in and solve for another slope. x2, y2, x1, y1. Right? We're almost there. I know this is a lot of work, but we're almost at the answer, okay? So let's plug them back in. We start with y2, because remember we're using the formula up here. y2 is 1 minus y1, which is 0, all over x2, which is negative 3, minus x1, which is negative 6. Remember earlier we talked about those two negatives become a positive. So we'll have 1 minus 0 on top, which is 1. And negative 3 plus 6. It's the same as saying 6 minus 3. And we get 3 on the bottom. So first slope is negative 2. Second slope is 1/3. They are opposite signs, so it does check off on the first criteria. That's the word I'm looking for. But then, are they reciprocals? Negative 2 would have to be 1/2, but the other slope isn't 1/2, it's 1/3. So they can't be perpendicular, which means it must be intersecting but not perpendicular. That is our final answer. So problem 1 felt like a doozy, but with some practice, it wouldn't be that bad. I've written all over this slide. So what you want to do is you want to make sure that you understand what the question is asking you and understand what your answers are telling you. If you can do that, you can generally dissect and get through almost any of those problems. It's just figuring out what they're asking and telling, right? And then it takes some work in between, which we did, and realize the answer is going to be A. All right, let's keep chug-a-lugging along. This is problem 2. Problem 2, the question is, how many solutions does the equation below have? I don't know. I don't know how many solutions it has. But according to my answer choices, it can have 0, 1, 2, or infinitely many solutions. So in order to do this, we have to solve for our x. So let's go ahead and solve for x, or we can try something else. We can take some numbers, plug that in, and see if it gives us correct answer choices. So there's multiple ways to do this. What we're doing is we're looking for how many solutions, so we're looking for how many numbers that can be plugged into x and give us a true statement on the left and the right-hand side. I like plugging and chugging, so I'm going to choose to do that. Remember, your answer choices are not the numbers that you have to plug in. They do not represent the x value. They're the number of solutions that create the proper answer. So I'll try saying that without having it sound the same. So the number of solutions is how many numbers can you plug in. So like if we used 5, 6, 7, 8, 9, and 10, that's 6 numbers. So let's say that C said 6, then we would choose 6 because 6 numbers work to plug into the equation to make it a true statement. So let's try some plug and chugs. Remember, we're looking for how many solutions. Well, I like the lower numbers, so just so happens I'm going to use 0, 1, and 2, but that doesn't mean they're the number of solutions. I'm using those numbers to see if I can get true statements. We can use any number. You can use 5, 6, 7. You can use 10, 11, 52. You can use any numbers you want to. I like 0, 1, and 2 because they're small numbers, they're quick numbers. I can get through the problem very fast. Remember, we're timed on all our exams, so we want to make sure that we're getting through it as quickly as possible. So I'm going to start plug and chugging. If I tried 0, I would take 0 and say my x is equal to 0. I would plug 0 in every time I saw an x. And I would hope that I would get an answer that is true on both sides. And we'll see what that means if this works out. So you always have to write your PEMDAS. Remember, we have our parentheses, our exponents, multiplication or division, addition or subtraction. I prefer to write it this way because once we get rid of our parentheses, remember we start from the left to the right, and if we see multiplication first, we'll do it first, but if we see division first, we'll divide, okay? So it's a preference thing. We'll start with our parentheses. So inside my parentheses here, I'll have 0 plus 2, which is 2. And just to reduce it on the outside, the 0 is not doing anything for us or against us, so I'm just going to kind of get rid of it. And I'm going to work my way to the right side. 2 times 0 is 0, so I'm going to keep my 4 inside the parentheses. Write everything else the same. All right, let's do some math. Negative 5 times 2 is going to give us a lovely negative 10 minus 4. And we'll have negative 3 times 4, which is negative 12 minus 2. Let's put them together, see what we get. Ooh, look at that. Negative 14 is equal to negative 14. So it looks like 0 is a solution. But what if we chose another number? What if? So let's try another number. Let's try x is equal to 1. I'm going to do it at the top. Let's not box it because we don't know if it's true yet. So try it again. Negative 5, put 1 everywhere that you see an x. Ooh, I'm going to run out of space. Let me try that again. I apologize. X is equal to 1. So we'll have negative 5 times 1 plus 2 minus 1 minus 4 is equal to negative 3 times 2 times 1 plus 4 minus 2. Lots of numbers, lots of words. Unless you're writing it, it just sounds like mumble jumble. Remember, we start with our parentheses. So we'll start with here. All right. 1 plus 2 is 3. Everything else the same. And to help us, we're just going to add these so we have less steps together. So negative 1 minus 4, I owe you $1, I owe you 4 more, I owe you $5. Start with our parentheses again on the other end. 2 times 1 is 2, and 2 plus 4 is going to give us 6. So we'll have negative 3 times 6 minus 2. All right, let's do some maths again. Negative 5 times 3 is going to give us negative 15. Minus 5 is negative 20. Do the math on the other side. Negative 3 times 6 is negative 18. Minus 2, so I owe you 18, I owe you 2 more, I owe you $20. Oh, well, look at that. It just so happens that x equals 1 is also a solution. So right now, A for 0 doesn't make sense because I have 2 numbers that seem to be a solution to the equation. So we have more than 0 solutions. We also have 2 solutions, which is more than 1 solution. So now we have to figure out if there's any other number that could possibly be plugged in to give us an answer, and we'd have to go with our last answer choice. So it's either going to be 2 or infinitely many. So let's just try the number 2 because I like 0, 1, and 2. Let's do 2 down here. We can fit it. I believe in us. So x is equal to 2. We'll have negative 5. Oops. Sorry, guys. Negative 5 times 2 plus 2 minus 2 minus 4 is equal to negative 3 times 2 times 2 plus 4 parentheses negative 2. All right? Remember, we always start with our parentheses, so let's start there. 2 plus 2 is 4. Negative 5 times 4. Then we are going to put those numbers on the outside together to make it a little less writing for ourselves. I owe you $2 and I owe you 4 more, so I owe you 6. Then we have the parentheses again, which this gives us 4, and 4 plus 4 is 8. Keep everything else the same, right? Do some math again, and let's see what we get. So, negative 5 times 4 is a negative 20 minus 6 is negative 26. And then we have negative 3 times 8, which is negative 24. 3, 6, 9, 12, 15, 18, 21, 24. 24, negative 24, minus 2, negative 26. Well, look at that. We have another number that so happens to work. So right now, we have 3 solutions, which is still more than 2. Well, they didn't give us any other answer other than infinitely many. Remember, the numbers we plugged in were not the actual number of solutions. It's how many answers we get that are correct are this many solutions. So we currently have 3 solutions. Let's write that in a different color. Just from what we did, we have 3 solutions. We have x is equal to 0, 1, and 2. We have 3 solutions, and 3 is more than any number that they gave us, and the only answer that fits is infinitely many. All right? I hope that's not too much of a doozy for you. Yeah, it's quite a bit of a couple steps, but sometimes it's worth doing the work. Let's dive into problem 3. It says, a student was given the following problem and asked to solve for x. They want to know, what step did the student make an error? Best advice is, don't look at what they give you. Right? We're going to look at the problem given and we're going to solve it ourselves because I know you know how to do math. Right? So let's do math on our own and then figure out what the student did. So this is the problem. Let's write it off to the side and let's work it through together. We have 4.5 times 3.1x plus 6.5 is equal to 7.9. Remember, we have parentheses, exponents, multiplication or division, addition or subtraction. So we're going to start with our parentheses. Is there anything to do inside the parentheses? I cannot combine this and this together. So nothing to do inside. I do know that this 4.5 on the outside can be multiplied in. So let's start there. 4.5 times 3.1 is going to give us 13.95. Keep the x, and we'll do it one more time. Remember, you can't give one kid without giving the other. If you're a parent, you totally understand. If you're a sibling, it's the same thing. If you have a friend that you're close to, there's no way you can just give them something without giving somebody else. It's kind of like a distributing thing. Hope you see what I did there. 4.5 times 6.5 is going to give us a lovely 29.25. And we're going to keep everything else the same. All right, I'm going to do one more step and then I'm going to take a look at what the student did. Well, right now, my next step tells me I need to move some stuff away from the x. So I look at the ex as an ex-boyfriend, ex-best friend, I don't know, ex-family member, ex-girlfriend. You don't like them for a reason, so get everybody else to the other side. We're going to subtract 29.25 on both sides. And we want to subtract because currently 29.25 is being added. So we have to do the opposite operation. So we'll get 13.95x is equal to negative 21.35. All right, I've done quite a bit of steps. Let's see what happened if anything happened that's wrong. It might kill some of you that I didn't solve for x. So I'm going to just write how to do it, and let's see if you get the same number after I tell you what the answer is. So we look at the steps and we say, okay, well, we started off the same. Here we go. There's our first thing. We started with the problem. Now we're going to actually do step 1. Step 1 is here. Does their step 1 look the same as our step 1? They have 13.95x. We have 13.95x. So far, so good. They have 6.5. We have 29.25. Who's wrong? Do you trust yourself? Because you should trust yourself. So it's not you that made the mistake. It looks like they made a mistake. You know what they did? They forgot to distribute the 4.25 to both terms inside the parentheses. So they forgot to multiply 4.5 by 6.5. They forgot to do it, which means that that is where they made the mistake. Their mistake is A, step 1. Once you see a mistake, there's no need to keep going. Some people say it easier as to just look at the steps and see if the math adds up. I personally find it easier to do the steps and see if my math adds up. And it's just a preference, so it's completely up to you. Remember, it's a test that you're taking and you're being timed. You want to get through these problems as quickly as you can. And remember, I told you I was going to tell you what the answer is, just so you know, in case you were wondering. When you do the last step, you divide by 13.95 on both sides, and it just so happens that x is equal to negative 1.5, which kind of also gives you a hint because their answer wasn't the same. Uh-oh. All right, we have another problem. Problem 4. It says, which of the following values satisfies the given equation? So now these are numbers that actually say x is equal to negative 1, x is equal to 0, x is equal to 1, and x is equal to 2. That is what A, B, C, and D actually mean. So when you plug them in, you need to get a value that, what? That satisfies, so it is a true statement to the equation, our lovely inequality over here. We have to figure out which number makes the statement true. So, how do we do that? It's a plug and chug, but I'll give you a hint before we start plugging and chugging. The problem reads, the inequality, 5x squared plus 6x minus 15 is greater than 0. So if it's greater than 0, I'm Gonna just start with the larger numbers because I'm looking for a number that's gonna give me such a large value that it has to be larger than 0. So I'm looking for big numbers. So my hint to you when you're taking the exam is start with the larger numbers for greater than. For less than, we'll start with the smaller numbers because we're looking for stuff to be smaller. So if I start with larger numbers, that means I'm starting with D. Let's try it out and let's see what happens. If I plug in 2 to all of my x's, I get 5 times 2 squared plus 6 times 2 minus 15 is greater than 0. Okay? Remember, we start with parentheses, exponents, multiplication or division, addition or subtraction. Okay, all of my parentheses, there's actually nothing to do inside the parentheses. Ooh, but look at that, I have an exponent. I'm gonna do my exponent first, because that's what it says to do. I'm gonna keep my 5, and I'm gonna say 2 times 2. Remember, that's 2 times 2, because it's 2 times itself. So 2 times 2 is 4, plus 6 times 2 minus 15 is greater than 0. Let's keep doing math. 5 times 4 is 20. 6 times 2 is 12 minus 15 is greater than 0. Okay, well, we're almost there. 20 plus 12. 20 plus 12 is 32. Minus 15 is greater than 0. Well, 32 minus 15, what is it? It's negative 17. I meant it's just positive 17. I don't know why I said negative. I greatly apologize. It's just 17. It's 17. 32 minus 15 is 17. Is greater than 0. Is that a true statement? Remember, our inequalities can be alligators. They like to eat the larger number. So 17 is larger than 0, which is a true statement, which means 2 is our answer choice. I'm not going to try any other answers because I got a value that actually gave me a correct answer. I'm not going to keep trying because that's going to take up time from my test. If you started with -1, you would have worked through other numbers. If you had started with 0, you could have started with any number you wanted to. My hint to you was start with larger numbers because we're looking for a number that is greater than 0. So I started with 2, and it just so happens I have winner, winner, chicken dinner. Problem number 4 is all done, and we're going to problem number 5. So, a lot of you see a word problem. A lot of you freak out because it's a word problem. We don't want to freak out. Words don't bother us. It's just a word problem. We just have to figure out what it's trying to tell us. If we can do that, then guess what? It's not that scary anymore. Word problems didn't do anything to you. Don't discriminate against them. So let's read it together. Let's take it step by step. It says, a ball is shot out of a cannon from the roof of a building. Okay. Its initial velocity is 30 feet per second. I don't know if it's important, but I'm going to highlight it. They give us an equation, and the equation reads h is equal to -16t squared plus 30t plus 65. It's probably going to be important, so let's highlight that as well. And we keep reading to say, can be used to model the height of the ball after t seconds. So this is telling us that h is the height, and the equation is there to help us figure out after t seconds where the ball is. Okay? It then asks, what does the number 65 represent in this equation? I'm not entirely sure. Let's look at the answer choices. Let's figure out what they're trying to tell us. the vertex of the equation, the time it takes the ball to hit the ground, the height of the building, and the maximum height of the ball. Well, if we think about what's going on, we know that t is the amount of time. So t is time. So if t is time, we have a number without a t. That number is a constant. It means that no matter what you do, 65 is always going to be there. So we have to figure out exactly what that 65 is trying to tell us. I'm going to read that first sentence again. It says, a ball is shot out of a cannon from the roof of a building. Well, if I'm thinking t is time, and I have this equation, let's figure out at 0 time, which is when I start, what the height is. So let's just look at it like that. We have h is equal to negative 16 t squared plus 30t plus 65. So if t is equal to 0, which is our initial time, it means where we start, this would go away because anything times 0 is 0, and this would go away, which means anything times 0 is 0, and we would be left with a height of 65. Where did I start with the ball again? It said that I shot the ball from a cannon from the top of a building. So this is my building, this is me, this is my ball. I'm not drawing the cannon. I apologize, I'm not an artist. But if I start at the top of the building and at 0 time, I am at the top of the building, the height of the building must be where I start, and I hope you see where I'm going with this, which must be 65, because that's where I started. I started at the top of the building on the roof. The ball hasn't gone anywhere, because remember we said t is equal to 0. That means the ball has gone nowhere. It's where we start. We're just standing there. So if I plug in 0 for all of my t's, I'm left with where I started, which is on the top of the building. So 65 must be the height of the building. Sometimes you don't really have to math, you just have to understand what's going on. They don't seem that bad now, do they? Moving on to problem number 6. Problem number 6. We see shapes, we see letters, we see answer choices, we see lots of stuff going on here. So we have to take a step back and try to figure out, what are they trying to tell me? Problem 6 says, which of the following is an example of an ABBA pattern? Patterns, 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 patterns. Patterns are going to tell us what they look like, but the ABBA is what it actually needs to look like. So I can do 1, 2, 1, 2. That's a pattern. It's repeating 1, 2, 1, 2. Patterns are repeating sequences, right? So they have something that we can see out of them. If I look at my answer choices, I'm looking for ABBA. If I think about it, the two things in the middle need to be the same, and the two shapes on the outside need to be the same. So off the bat, I look at D and I say, is my first shape and my last shape the same? They're not. I look at C and I say, is my first shape and my last shape the same? They are not. Let's try B as in boy. My first shape and last shape, are they the same? Wrong answer. So I'm only left with the answer that makes sense. If I named the circle A and I named the squares B, I have A, B, B, A. We named the circles A because we knew that the outside shapes needed to be the same, and we knew that the inside shapes needed to be the same. If we look back at B as in boy, we have A, B, A, B. If we look at C, B, B, A, A. And if we look at D, B, A, B, A. Just to give you guys some extra background on what the other answers are telling you. But you want to make sure you're looking at what they're asking you about and trying to figure out what they're telling you. They're asking you about a pattern that represents A, B, B, A, and we figured out that the outside shapes need to be the same and the inside shapes need to be the same. Sometimes they're just that easy. Remember, A is our answer, and let's chug along to problem number 7. Problem number 7, it reads, which of the following is equivalent to the number 582? That seems pretty easy, 582. But then these answer choices, man, I'm telling you, they're just not as simple as I thought they were going to be. So let's start with D and work our way backwards. If we have 582, just looking at the problem, we know that we have 500s, Eight is in which place? 5 is in the hundreds place. 8 so happens to be in the tens place. And 2 is in the ones place. So if I'm just thinking about it, I will have 5 hundreds, 8 tens, and 2 ones. But D doesn't give me that. They give me 5 hundreds, which just so happen to work out. But I don't need 82 tens. If I do 82 tens, I get a larger number than I'm anticipating. So let me tell you what that 82 tens mean. We have 82 multiplied by 10. That gives us 820. Remember we started with that 500s? Guys, no matter how I add this, I'm not going to get 582. That's just not right. D is not an answer choice. Let's look at C. Looks like an easy one. We have 500 plus 8 plus 2. You don't want to just look at it and say, oh, that's the answer. Let's actually work it out. 500 plus 8, which is a 1, it's in the ones place, and a 2, which is in the ones place. When I add that up, I get 510. Guys, ladies, gentlemen, that's not the answer we're looking for. Remember, we're looking for 582. B says to minus stuff. There is no way I'm going to subtract and get the answer I'm looking for if I'm starting at 500. So let's look at what the answer actually is. A is our answer. A says 58 tens. Okay, so if I have 58 tens, I have 58 times 10, which is 58 times 1, which is 58, and bring over the 0. So I have 580, and they're telling me I have 2 ones. So I have 2. When I add that together, guess what? Winner, winner, chicken dinner. Our answer is A for apple. It's not that hard once you start figuring out what those words mean. So our answer here is A. We have 58 tens, which is 58 times 10, which gives us 580. And we're adding 2 ones, which is 2 times 1 to give us 2. Add them together, and we get the answer that we started with, 582. All right, let's do one more problem. Might have room for 2. Let's see. Maybe. Make no promises. All right, here's another word problem. A lot of you, I can hear the sighs. I can hear the stress. You're like, it's late in the evening. I've had a long day. Stop giving me word problems. We're not discriminating, remember. So we read the word problem and we read it strong. And it says, Derek has a bag of cards, of number cards. Okay, it's information. There are 10 cards in the bag numbered 1 to 10 with no repeating numbers. Okay, so we have 10 cards, they're 1 to 10. No repeating numbers. He and 4 friends take turns pulling a card out from the bag and replacing it in the bag. Okay, that sounds pretty important. So they're taking out cards, but they're putting it back. So it means they're not keeping it, they're putting it back. It then says, the first 3 people pull out an odd number, okay? And they want to know what the probability is that the 4th person pulls out an odd number. Well, first, let's figure out what's in the bag. Remember, we have 10 cards and they're 1 to 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? Those are our cards that are in our lovely bag, right? And we're talking about pulling out odd numbers. So let's just figure out what our odd numbers are. Well, odd numbers are numbers that can only be divisible and multiplied by 1 in itself. So we have 1, oh, that's not an odd number. Odd numbers are not even numbers. I apologize. Sometimes I just get ahead of myself with math. It's 1, it's 3, it's 5, it's 7, it's 9. I'm crazy. Don't listen to me. Odd numbers are numbers where it's not evenly divisible by 2. So if I took 1 slice of pizza and I tried to split it between 2 people, you wouldn't get a whole number. You would get half a slice of pizza. Where if I had 2 slices of pizza and I split it between 2 people, everybody gets 1 whole slice of pizza. So it's a whole number compared to a part, a fraction, or a decimal. That's what an odd number really is. So when we look at our odd numbers, we have 1, 3, 5, 7, and 9. Our answer choices are in fractions. That's our hint. We need a fraction. Fractions are part over the whole. Fractions are also what we're looking for. Over the total. The second one is going to help us a little bit more because of the type of problem that we have. So what are we looking for? The person is going to pull an odd number card. So we're looking for an odd number. And we're looking for the total amount of cards. So remember earlier I told you that it's important to know that we're not keeping the cards. So the first friends that went and pulled, they put the cards back, which means that our total is always going to be the same. So we still have 10 cards in the bag when the 4th person goes to pull the card. We also have all of the odd number cards in the bag. We have 1, 2, 3, 4, 5. 5 odd number cards out of 10 cards in total. That looks like a reducible fraction. So 5 goes into 5 and 5 goes into 10. We're going to divide the numerator and the denominator by 5. And what do we get? We get our answer. And our answer is 1/2. Okay, it matters how the problem reads. So it matters how we answer this question, right? There were a couple things we needed to know. We needed to know how many cards there were that gave us our total. We also needed to know this very important information that I told you we needed to know earlier. I'm going to say it one more time. Replacing the card back into the bag. It means that our total did not change. If we kept that card, this would be a very different problem. So it would read more of and did not replace the card, or they kept the card. Those are words we want to be looking for because that changes how the problem gets solved, right? So we want to make sure that we're getting through everything together and we're reading through the problem and not misinterpreting anything, right? So that is how you solve it. That is how it is done. We don't have time for the last problem, but I can give you a hint. I'll give you a hint and I'll give you the answer, and I want you to take time and sit down and solve it. I'll read it very quickly so we can get through it, just so you get it a little extra in. So we have this biology teacher. We have the scores that the students made, and she wants an average of 80, but she has all of this. They tell us that a student is missing from all of the scores. Average. Average sounds like something we all know. Average is the same as saying the mean. I'm going to give you the answer, but I'm not going to give you how to solve it. That's you're going to do together or by yourself or call a friend. So if we have the average and we know the average they want is 80, we have all of this information, which I'm going to just put this here, plus our absent student divided by the number of people in the class, which is 10. I think it's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, and the absent student, which is 10. So if you do this properly and you solve for your x, guess what? You'll get your answer. And I'm just going to say that the answer is somewhere on this page, and it's there. Do it out, work it out. You guys are going to pass because it's when you pass, not if you pass. It's when you do it.
All right. Well, thank you, Priya. Awesome job, Priya. Priya is our guest host here this week, and I'm sure you'll see her sporadically around. And she does offer one-on-one math tutoring on our Learning Liaisons website. So I put the link in the comment box too. So if you need a little extra support in addition to our video boot camp, she's available for tutoring one-on-one. So I want to thank you guys for watching us. We are coming up on the 60-minute hour here. So thank you. A couple of last-minute things. Number one, if you want the slides, that is, the information is on the screen there. Text MathStream1 to that phone number. It'll ask you your name. It'll ask you your email. And then I'll fire off a PDF. We do keep this online for about a week on our YouTube channel. You'll see a couple of our sessions, but we're here every Wednesday night. So a lot of people are asking, some people asking in the comment boxes, what exams do you prep for? These are skills that are on all the different grade levels. So whether you're K through 6, 5 through 9, or 4 through 8 for our TExES peeps, 6 through 12, or 7 through 12 for our TExES peeps, we do stuff for Praxis, Florida teacher exams, and TExES prep. But heck, if you're watching, it doesn't matter what state you're in. If you're doing a different test like CBEST in California or the different ones in Minnesota, it doesn't matter. Math is math. All the concepts are the same. They just have different titles on the exam. So we thank you for joining us here tonight. If you have any questions, you could always reach out on our website. There's a contact button. We're always here to help you. And like Priya said, always remember, it's when you pass, not if you pass. See you next Wednesday. Hope you guys have a great rest of your week and a rock star weekend, and we'll catch you next Wednesday night. Thank you.